Welcome to EDU World Space.
Hello, welcome to this lesson. In this lesson, we would evaluate the triple integral. So we'll do the integral with respect to y, then we'll move to respect to x, then respect to z. Right. So let's have it this way. So integral from 1 to 2, then integral from 0 to 2z. So let's evaluate the innermost integral. We have x e to the power negative y dy. So by evaluating the innermost, we would have the integral from 1 to 2, integral from 0 to 2z. Then this becomes the x is a constant here and the y is a variable. So this becomes e to the power negative y all over negative 1. And evaluating it from 0 to lane x. All right. And this is dx dy. All right. So here the negative can actually come out. So we'll have integral. Let's have negative one here. So integral from 1 to 2, then integral from 0 to 2z. All right. And this, if we put in the values, we would have x. Then this is e to the power negative lane x. Actually, we can have a negative number there. All right. And this is dx. Actually, I'll put the, we also have to put the 0 in there. So this is minus x e to the power negative 0 on negative 1. All right. This is the x, the z. So evaluating the innermost still, here the negative 1 steps down. So we'll have negative x on negative 1, then e to the power ln x. Then this is plus because we have negative and negative there, and that becomes e to the power 1, e to the power negative 0, which is the whole thing is 1. So this becomes x, right? And that is the x, the z. So integral from 1 to 2, integral from 0 to 2z. The negative and negative goes away, and that becomes x, and this and that goes away, so we have another x, and this becomes 2. So x squared plus x, we have dx z. Okay, so now we can have integral from 1 to 2. The our new innermost integral becomes this. So x squared plus x, we have dx. Okay, so going forward, the integral from 1 to 2, let's integrate this. We have x to the power 3 on 3 plus x squared on 2. We're evaluating it from 0 to 2z, and this is dz. So this becomes the integral from 1 to 2. And if we put in 0, all goes to 0. But if we put in 2z, that is when we have a real value. So let's put in the 2z first before the 0. And this becomes 4, actually, that is 3. So this is 2z to the power 3. And this becomes 8z to the power 3 on 3. Then plus, here would have, this would be 4z squared divided by 2. So this becomes 2z to the power 2. And this is the z. All right. So the next step, we only have the integral from 1 to 2 of 8z to the power 3 on 3 plus 2z to the power 2. We have dz, which will then become, so here would have 8 on 3, then z to the power 4, this is times 4, all right, and this is plus 2z to the power 3 on 3, evaluating it from 1 to 2. Okay, so here would have, now let's see if we can simplify. 4 can go into 8 two times, so that makes it 2 on 3. Okay, we have z to the power 4 plus 2 on 3, z to the power 3, and we are evaluating it from 1 to 2. Okay, you can bring the 2 and 3 out because that's a constant, and we'll have z to the power 4 minus z to the power 3. All right, so this becomes 2 on 3. If we put in the boundaries from 1 to 2, we would have 2 to the power 4 minus 2 to the power 3, then minus 1 to the power 4 minus 1 to the power 3. So this becomes 2 on 3 and 2 to the power 4. So this is 16 minus 8, then plus, this is 1 minus 1, which is 0. It's actually minus. So this becomes 1 minus 1. So we have 2 on 3. And we would have, so this goes to 0. So 16 minus 8 becomes 8. Right? And this is equal to 16 on 3. Right? So therefore, the triple integral we have from 1 to 2, from 0 to 2z, so the whole of this integral is 16 on 3. All right, thanks for your time. This is the end of the lesson.